Hey everybody, Merlin the mechanic here again. Just going to recap some of the things that we went over, and then maybe today just work on the master cylinder and a kind of a tear down and describing, let's say, the pistons and the seals inside that. So let me just grab this guy and go over here one more time. So looking at, let's just say, our master cylinder, after we figured out our brake pedal ratio, we times it by, let's just say, our input force to the pedal times our ratio, which was great. So then on our top Pascal's law, we figured out the force going into our master cylinder was 325 pounds. Let's just say then we could calculate the area. Once we knew the diameter of that piston, we were able to calculate it out. So the unknown would have been the PSI, a product of, moving the fluid. So then of course 325 divided by the 0.701, let's say, inches wound up being like 665 PSI. That's why, we're using inches here, but we want to stay in the same scale, right? Because we're using PSI, right? And so you have to, keep things the same scale. Okay, so from there, let's just say, that was the force going in, so 325 pounds. Like I say, I was, I even stated, I noticed I even wrote it when I looked at my videos, because I got to admit, being behind the camera is different than being in front of a group of people, and so you tend to kind of go on. So I kept on stating basically torque when I was saying pounds a foot, just from... I have a habit of doing that, but I mean, it's pounds, just like you stepping on a scale. Okay, so then looking at our caliper to say we figured out, let's say we knew over there we had 665 going in, so we had to figure out the surface area, because our master cylinder was taking force, and then output was going to be in PSI, and yet our caliper is going to be taking PSI, and the output is going to be force. So okay, so we figured out the diameter divided by 2 to give us a radius. We squared the radius to find, and then we had to work out our area. So pi times radius squared, and that equaled, let's say, 4.4, let's say 3. And of course, we timed that basically, let's say, by, of course, the pressure. Since we knew that we had 665 going to it, and we knew we had an area, let's say, of 4.428. And then, these two times each other, so 4.428 times 665 equaled, 2,053 basically, say output pounds of force. So of course, so definitely pretty impressive, considering all I did was, I would say, immediately stepped on the pedal. Okay, so now that we know that, and you guys can figure out all the rest there that I've got posted on there. So okay, so let's take a look here at the master cylinder. So just a little bit more kind of like tear down and what do we see inside this guy? Well, like I say, the first thing what I talked about, and I think in the first video, was that the cap is pretty important. We got to seal the brake fluid, let's just say, from of course moisture and everything. So and of course, so that means we need a barrier in between, Now the problem is as your brakes wear, so as your brake pads wear, so sitting here, at a caliper, and there's, your friction material, let's just say, sitting in there. Let's just put these. So let's just pretend these pads aren't actually for this particular unit, but close enough. So let's just say they're sitting there. So you got your rotor in between, but as these pads wear, of course, you got this piston can't, like, look at all that travel there. I mean, your master cylinder with that piston, let's say, diameter, only moves so much fluid, let's say, within its, normal stroke. So of course, this is where, I mean, if you didn't, after a brake job, and you pushed your piston back inside the caliper like this one, and then of course your first brake pedal would be right to the floor, you actually have to move this piston over. So it's kind of, this piston will move out, as further as it has to go, and then it'll stay there and just pull back a little bit from as the pads wear. So in other words, as these pads get thinner and thinner and thinner, this piston's got to move out and stay out, say further and further and further. So what that means is, imagine the volume behind here. I mean, we've got to keep it full of fluid. Behind that piston, it's got to be kept full of fluid. So your reservoir is going to go down. So you'll see here, like I cleaned this master cylinder so it didn't look so crappy. Let's say this is an old one off of a 95. But you see here it says, min and min kind of thing on this guy. So of course you got your max and then your min, and you'll see this guy is kept on an angle. That's why they differ. But I mean, through normal brake, let's say life, it's going to go from max down, down not quite to min, but pretty close to min if your pads are almost wore out. I mean, like going beyond normal, right? And that's normal. So it's not like you'd top up your master cylinder then, because if your brakes are worn out, imagine if this piston's all the way out as worn brakes go, and then of course you topped up that master cylinder, and then you went to do a brake job and had to put new pads in here, and your rotor to fit in between there. That piston's got to wiggle back in. So you push all that back in. Where's the fluid going to go? I mean, the fluid doesn't compress, right? Like, where does it go? Something's going to have to spring a leak here. If you're lucky, it'll just blow the cap off. If you're unlucky, maybe blow this seal off. So that's why normally when I push a piston back, I usually, just pop the cap off slightly while I'm doing it nice and slow, just in case someone has topped up this master cylinder when they weren't supposed to. If you're working like at an oil change place, I mean, if this is halfway down, let's say, and it's not touching the min whatsoever, all you have to do is look for leaks. If there's no leaks in the vehicle, you don't top that up. You don't know how far the brakes are worn down. If you top it up, the next brake job is going to do, all it's going to do is pump out a bunch of brake fluid all over, let's say as it's coming out, and of course brake fluid attacks paint, so you got to be careful. So okay, so as that, say, a volume inside here is increasing because of the pads wearing, and it's so in other words, we need, of course, we're going to have an atmospheric pressure on top of this diaphragm. We got to seal the brake fluid. Let's just say God damn it, a mosquito just bit me in the head. We got to seal the brake fluid, let's just say, from the atmosphere, just so we don't get moisture in the brakes, like I talked about. So I mean, but we need atmospheric pressure to be pushing down on here, to make sure that we don't cause a vacuum inside the brakes. And so that way, when the volume's going down, you see atmospheric pressure can push on these diaphragms, and that allows it to go down, while still staying sealed. So the cap is and the diaphragm is a very important device, let's just say, in your brakes. So that's pretty cool. So every time if you have a hydraulic blowout, these will be pushed down, and then you gotta push them back, fix your hydraulic line, and of course, and then you're good to go. Okay, so the master cylinder, let's say, we took out, let's just say, the pistons already. So there was two pistons. So here's my forward port and my rearward port. So of course here's the forward piston, and this is the rearward piston. So this piston, where's my marker? This piston here at the back is your primary piston, and this piston here at the front is your secondary piston. Okay, so on each piston though, there's special seals. So this is where it kind of gets, say, confusing. See, this is a lip seal. If I looked at it real closely, well, there we go. It's a lip seal. So the hydraulic pressure, like this guy's sitting, in front of this output port here, right? And so then, as this guy gets shuttled forward, this lip seal lips against the bore of the master cylinder. Like, let's just say there's my master cylinder. That lip seal is going to be, lipped forward like this, and there's my piston, and so then let's just say here's my outward ports, going out. So then, pressure being built up inside this guy is going to actually help seal. Those are little arrows, by the way. I'm still trying to look through the damn camera and do that. It's going to help push those seals against, let's say, the master cylinder wall to make a good seal. You know, and then as this piston keeps on shuttling forward, let's say, of course, your brake fluid is going down through here, you know, and going to your brakes, you know, in this primary piston. So the primary piston, now, even though this is the primary piston here, so here's your primary piston, but this is the primary seal then on the primary piston, because it's the one sealing the hydraulics. This one here is actually called the secondary seal. You know, in reality, the only thing that seal's doing right here is stopping external leaks to go out the master cylinder. You know, and even if you see the brake booster over here, this older one, let's just see here, brake booster side. So if I look at this brake booster side, you'll notice this little trail here and rust. Then, in other words, the paint's all gone. That would have been a secondary seal leaking, and of course it eats the paint off it. So that's a classic indication of a secondary leak, a secondary seal leak on the primary piston. Okay. So each piston then has a primary and a secondary seal, but those are seals, right? So those are seals, you know, say on there. So, you know, secondary seal on the primary piston is the back one, and of course the primary's, let's say, piston's primary seal is the front one. It's the lip seal. Okay, so now let's look at the secondary piston. Okay, so let's get it to focus here. Okay, so you'll notice this is also a lip seal, and it's of course going to be sitting again in front of this output hole. You know, so okay, so then it is also, when you look, you know, look there, it's going to have, I'm just going to crudely draw it, a lip seal here, and this is going to be my out, right? And there's the end of your master cylinder. So this again is going out to, you know, 1/2 of my brakes per se, right? And of course, so okay, so this one is then since it's on the hydraulic side, this is my primary seal on this is my secondary piston though. Now, the one thing about the actual secondary piston, the rear seal, you know, so which is the, let's say, secondary seal in the secondary piston, is actually also a lip seal. And it's facing the opposite way. And the reason why that is here, let's